next we will look into mutation testing. Okay, mutant coverage or mutation testing can be seen as a measure of testing quality. So we have statement coverage, which tries to tell whether lines of code are executed by the test, and then this is the testing quality for statement coverage. For mutants, we automatically modify the source code, and now the question is, do we detect errors caused by the mutants by executing the test set? So think about that for a while. We make automatic modifications to the program source code. After the automatic modifications, we run all the tests. If the tests fail, then they have killed the mutant. So we have covered this mutant, it's not a problem. But if we modify the program source code and the test still passes, then this mutant survives. And then it indicates we have not properly tested the particular mutant that was causing the modification in the source code. Okay, so what are those modifications? Well, they can basically be any type of modification. Here we have a program that returns the max of A and B. So if B is greater than A, then the B is returned, otherwise A is returned. And now a possible mutant would be to change this operation here to equals 2. So this wouldn't actually change the program behavior in any way, and I doubt that there could ever be a test case that would actually detect it, because this only considers the case when they are the same. There are many possible mutant operations. We can change the relational operator from greater than to less than. We can change the logical operator from or to and. We can change the arithmetic operator from multiplication to addition to subtraction, and so on. We can change the name of a particular constant in a program or its value. We can change the variable name or the initialization value. We can change, or we can even delete a statement. Mutation testing was originally proposed already in the 1970s. However, as it is very computationally expensive, it was sort of forgotten as an interesting idea, but something that could not work at the practice in the time. However, with the modern computers, it is actually possible to do this mutation testing with real software. To understand why mutation testing is computationally so expensive, consider the number of modifications we can make to this if statement. So this if statement on the screen tests whether it has to be that A or B is true. This is an or statement with the brackets. And the type of mutations we could perform here, well, there are quite many, almost endless as it seems. So we could change this from logical OR to bitwise OR. Now this would be a different comparison. We could change this to AND comparison. We could change this to bitwise AND. We could change this to equals to comparison. And this would be really tricky. We could even change this to assignment. So this is not comparing A versus B. At least it's not doing that in C. This would be assigning the value B to A. And this would actually go through many of the compilers. I'm not sure if Java compilers would actually allow this. So many of the mutations would be rejected by the compiler. This might go through or this might not go through, depending on the compiler. We could do A greater than B, and so on. We could even delete the statement. So you can see, we only studied this one if statement, and it was quite easy for me to come up with 7 different possible modifications, and I could have keep adding those. And why this is computationally so expensive? You should understand that for each mutant we typically require a compile and run tests to study whether the tests can find this change. So if we go from A or B to A and B, we need to compile and run the test for this mutant. If we go from A or B to A is equal to B, then again we need to compile and run the test. And this is only one line of code. And if we consider we have thousands of lines of codes, well, we easily end up with thousands of compilations and test runs per program, probably even millions. So therefore, I mean, good tooling is really, really essential in mutation testing. Okay, we could do some measures into mutation testing. We could have mutation score, which would be killed mutants divided by the total number of mutants. The slight problem with this measure is that the total number of mutants is almost infinite. So if we have 1000 lines of source code, I think it would be easily to generate at 10,000 mutants at least. Then another possible measure is to normalize the number of mutants per 100 lines of source code. So you take the mutants, the survived mutants. So we take the survived mutants divided by the lines of code and multiply it by 100. So therefore we know how many survived mutants we have per 100 lines of code. So let's have a look at some axial mutants from an example program. So you can see the source code on the screen, and this is the same tool you will be using in the exercise. So we can see that there is a red line with number 1, and if we hover on top of that, we can see that removed call to this class Java util Gregorian calendar, and it survived, meaning that this call was removed and the test case still passed. And it's the same thing in here. So this statement could be removed and the test case would still pass. And as far as I can remember, it had something to do with some Gregorian calendar's undocumented features that existed when I created this program. Okay, then more mutants. Add spouse, negated conditional. So it flipped this conditional, it said it survives. So this tests whether the valuable female is true, and negation to this statement still passes the test case. So the mutant survives and the test case should somehow address this. We can see in the source code that this tries to do something with whether using the gender information to always add the female as the second. Yeah, and male is always first. So this is the way this is programmed. However, there is no test that actually tests this. So there should be. Okay, so looking at another one, it says removed call to family tree person model, add a relation, killed. Now this is a mutant that didn't survive. And here is another example of that as well. So overall, this mutation testing can be quite good way to ensure the quality of your testing, assuming that you have a good tool that you can use.